Welcome back to the Law of Relevancy podcast. I'm Cord Zoen, your host, and today we're joined by Jeremy Nashed. He is doing one of the things that is a very essential part of the invention process, and his business is located right here in Tampa Bay. Jeremy, thanks for joining us.
Thanks for having me, Cords.
Well, I got to be honest with you. I got to come clean here. So I went to the same college as you, and I'm so jealous because I didn't make very good grades, and by the time I found out about industrial design, the school wouldn't take me.
Well, I actually wasn't an industrial design major. I'm a mechanical engineer.
Well, that's how my grades got so crappy, because that's how I started off too. I was a mechanical engineer, and what I found out about mechanical engineering was that there's really only one answer to, like, what are the vectors on that light pole, right? And so there is no creativity involved or whatever, and so it was really difficult for me. And so I fantasized about being involved in what I saw over in the architecture department with industrial design. And that school is actually really, really good, isn't it? Isn't it one of the top ranked in the country?
It's one of the only in the country. Industrial design is a very niche discipline.
Well, but it's such an essential part of invention.
Absolutely. And forget about invention. The entire world around us, basically everything that we interact with, has been touched by a mechanical engineer or an industrial designer or somebody who's looking at it through an industrial design or iterative design framework.
I mean, even at this solo cup here, or this is a hefty cup. Sorry, Hefty, didn't mean to insult you. But anyhow, this hefty cup even would have had to have gone through some kind of an industrial design process.
Oh, absolutely. An extensive process.
And not just in its form factor, but also in how you produce it.
Design for manufacturing. Absolutely.
Well, tell us a little bit about what the processes that are involved. And so let's say I'm an inventor and I've got some great idea. I'm one of the only inventors these days who has an actual product idea instead of some app. And so I'm out there and I'm like, okay, I have to make this thing. Where do you come into the equation?
Yeah. So chances are you're probably coming to me and you already have at least one solution in your mind. Mm-hmm. The first thing I'm going to tell you is I'm going to say, let's take one step back and let's make sure that we really understand the problem. Because what you don't want to do is you don't want to pour money into a problem that nobody has or that you've assessed even slightly improperly. That would be a tremendous waste, right?
So how do you do that? Do you get out the prototypes and you start playing with them? What do you do?
So defining the problem can be anything from, say, talking to somebody who's an expert in that field, or maybe doing market research, speaking with customers, getting a feeling for what they think of that problem, where their real pain points are. Anytime you encounter pain, that's an opportunity for a product.
And that, to me, from what I understand, is anytime you encounter pain, when you actually have a solution for a problem, that's way more powerful than just some incremental improvement to
Absolutely.
Something.
But what we would say is once you've really defined your problem statement well, then we move into the solution space. And the goal is not to come up with the first solution that comes to your mind and run with it. It's to come up with as many solutions as possible and then weigh those solutions against each other, determine which is optimal in terms of manufacturing, cost, which meets the user's needs the best. And then we move forward with that one.
So is that expensive?
It can be, but that's where industrial design comes in.
Okay.
Industrial designers are trained to iterate on concepts inexpensively. You ever seen concept art?
Sure.
Yeah. So that's a discipline, even as beautiful as it looks, they're trained to be extremely efficient with the way that they draw their concept
tell me a little
art.
bit more about concept art, because everybody might not know what that is.
Right. So a concept art can be something like a very simple but very elegant sketch that gives you a picture of what the product is.
I see that all the time in automotive.
Yeah, it's absolutely. You see it on car commercials all of the time.
Mm-hmm. And so you go through some of this discovery process, and now you're actually trying to translate some of those words into drawings. And then I would imagine, especially in today's day and age, that you're using CNC machines for milling or 3D printing to start manifesting this thing into something that lives in the real world.
Yeah, absolutely. So you're hitting on the whole process spot on. There's a step that comes in between there, especially when it comes to physical products, and that's CAD design. So, let's say we've defined the problem statement, then we've iterated on a bunch of concepts. We've selected that concept. Then we move forward into what we call the technical design phase.
Okay.
A big part of that for physical products is CAD design. So this is where somebody like a mechanical engineer comes in and they use advanced software tools to model every fine detail of the product. And when they're doing that, they're thinking about, what does this weigh? How ergonomic is it? How easy is it to manufacture this form? And from there, these CAD tools can output files that can be easily interpreted by manufacturers, and then they can go into CNC or 3D printing or mills or any piece of capital equipment.
And so, and there's even technology nowadays, from what I understand, that allows you to even do some of that prototyping and testing in the software. Like you can actually see how geared, like you could wire the whole thing up to where you can see it move, right?
Yeah, there's simulations. FEA would be a great example of that. Fluid dynamic simulations would be another great example
What's
of
FEA?
that. FEA is, this is getting a little bit into the weeds.
I'm a nerd. I am really geeking out on this. What is FEA?
FEA stands for finite element analysis.
Ah, yes.
It's a numerical method. It's a way of approximating really complicated engineering problems, essentially. And it's not something that's fun to do on paper, but it's very easy to do in computers.
Gotcha.
So like the classic example of an FEA problem would be a beam that bends, that has some kind of load on it and deflects. And believe it or not, that's an extremely complicated problem to do on paper. But a computer can approximate a solution to that using finite element analysis very easily. So that's the kind of thing that finite element analysis can do.
Well, that sounds super technological.
Yeah, absolutely.
And so inside of that software, I guess you can, like if it passes some of that, or if you can afford to have that done, then you can start creating these prototypes.
Yeah, and sometimes that's necessary, sometimes that's overkill, sometimes intuition is enough. Like if you've got a hokey piece of plastic, you know that, okay, this is going to do the job for this relatively simple consumer product.
Gotcha. Right? Well, like even this cup, like what I really like about it is it's got these sort of finger grooves.
Yeah.
So I would imagine that was tested with a few different people's hands. But
absolutely.
It is definitely an improvement over the beer pong equipment I was using, you know, in all of my years of college. I do like this part of it. So let's say I'm an inventor. So I work with, I have some idea, or maybe I have some kind of a prototype I've created in my garage or whatever. So I need to select an industrial engineer or a mechanical or an engineer to help me create this thing, right?
Right.
Because there's a part of those drawings or that fabrication or whatever that's part of the patent process.
Yeah, absolutely. And I would go a step further, and depending on who you are, depending on what the product is, you're probably better off, rather than hiring an engineer, going with a firm that has a diverse set of disciplines that can tackle this problem. Because the things that we're buying, the things that we're developing are becoming increasingly and increasingly complex, and they require input from a lot of different
Almost
firms.
everything is a circuit board now.
Yeah, exactly.
Right. So you have maybe computer engineers, electrical engineers, you have material science engineers, mechanical engineers, and then an industrial designer that needs to take all of that and fit it inside of that form factor.
Right. Well, I think that industrial designers really thrive in that early stage of the process, like that problem defining, concept iterating stage of the process. And then there's like a handoff to engineering. And then that's where the technical design phase takes over.
Okay, so that's interesting. So let's come up with the form factor first, and let's work back to how we're going to fit the circuit boards into the thing itself.
Yeah, exactly. Or just the concept of what the main features are that this product offers. And then we go to, say, electrical, and we say, how do we wire this thing to do that? What are the primary components that we need in order to create those features?
Well, let's talk about one of the projects that I saw on your website. So you actually did a project for the Large Hadron Collider.
Yes. So that was a very atypical project for us. We were approached by, this is actually a research group at Northern Illinois University that has a partnership with CERN. And that was specifically CAD maintenance on a piece of production equipment that supports that project.
Yeah, I saw it was some kind of a punch.
Exactly.
That punches out wrapping for something inside that machine. It's the largest machine in the entire world.
Yeah, exactly. And it was super cool to have some kind of small contribution to that. The way that it was explained to me is that there's tens of thousands of photosensitive tiles in one segment of the collider. And in order for those tiles to be functional when they get to the collider, they have to be protectively wrapped before they get there. And so this is the piece of equipment that punches out all of the wraps that go around those tiles before they get installed.
It reminds me of, you're probably too young to even know what this is, but we used to have to use film in cameras.
I remember.
And so this, we'd have you couldn't let that negative get exposed to the sunlight or else it would ruin it. So I would imagine that those photo cells were so sensitive that you had to create, and they were probably custom designed. You probably had to create custom wrappers to protect them.
Yeah, almost certainly. So at some point in the design iterations, they wanted to create a new profile for the wrappers, but the research team lost their CAD designer.
What?
Yeah.
That's crazy.
Graduate student, went on to do other things. So they said, hey, these guys are an extremely agile team of engineers. They must have a professional CAD designer on their team who can hop in and without a lot of introduction and a lot of legwork can do what we need to do and then export the files for us to take up elsewhere. Gotcha. And that's what we did.
That's exciting. So how does an opportunity like that even come to you?
Some of them come to me. Most of them, I have to go find them.
So in this particular case, is there an RFP? Was there a design competition or what was the process to get a job like that?
On that project, believe it or not, the head researcher at the university reached out to me on, you ever heard of Thumbtack?
I've heard of Thumbtack.
Yeah, it's sort of similar to Angie's List, which is something I was experimenting with
How
for a
in the
while.
world did he find you?
Yeah, I had set up a profile on there, and I was experimenting with it for some time, as I've experimented with a whole number of freelance websites and job application websites and social media networks, and that was one where we got a ping.
So the machine that many feared would create a black hole that would swallow the Earth is using Thumbtack to find engineers to work on very important machinery.
You could say that.
That's great. That's really great to hear that. That's amazing. All right, so that's one way. That's really interesting. I like how you used modern gig economy type outreach to find that and track that job. That's super cool. And,
yeah, I appreciate that.
And that is one of the most famous pieces of machinery on the planet right now.
Exactly.
So then you've got some other projects. I saw one of them was one that we've probably all seen that looks like a little docking caddy for or corral for these little scooter bikes that we see all over downtown.
Yeah, absolutely. Yeah, Hopper is the company that operates the rideshare micromobility system here in the Tampa Bay area. That rack system is for their system that got deployed in Rochester, New York last year. And so we're expecting that it could be deployed all over the country eminently, but it first ended up in Rochester, New York. And that was actually an extremely quick project. They approached us in March of 21, and they said, we are deploying in Rochester this summer.
Yeah.
And we were told...
You've got 3 months.
Exactly. Yeah. And we managed to turn around for them that quickly.
That's really cool. So can you tell us a little bit more about that particular project? Because I love digging into some of the mechanics of how things get done. Sometimes people are like, well, I did this amazing thing. Well, I'm always curious going, well, how did you actually do that?
Yeah, absolutely.
So they approached you again. Was this also through Thumbtack or something else?
This is even stranger. Okay. This was through Indeed.com.
So they were looking to hire somebody that did what you do, and you were like, hey, what if I just contract this? Or they were more looking for a freelance designer. Okay.
And I presented myself as not just a freelance designer, which I am, but a designer who has a team of designers behind me.
Okay.
And they found that appealing.
Gotcha. So On Indeed, obviously they are, look at what you were just talking about. They're looking for some contract work or whatnot. It sounds to me like as a young entrepreneur, you're being very effective at going out there and like hunting for these jobs.
This business is very niche. The thing about this is not everybody's designing custom products, and even if they are, they might not be designing custom products right now.
Okay.
So my approach up until now has been a very targeted approach.
Targeted in what sense? Like you're only looking for those types of projects that you want to work on?
Or rather, I'm only looking to have conversations with companies that I think have a potential to work for us or work with us.
Okay. Well, I think one of the things that is very interesting about your business model, and we're seeing this more and more, is that you don't really have like an office space.
Nope.
You're 100% virtual. How big is your team?
We have 9, besides myself, contract engineers and designers.
And so a lot of people, when they think about working virtually with a team, they might be thinking, all right, I'm going to send it over to some other time zone. They might be 12 hours away, but you're actually all located in the United States.
Yeah, that's correct.
And so I can work with United States educated talent and do it virtually.
Exactly.
Well, I think there's a lot of advantages to that.
Oh, there certainly is. Right now, the kind of options, the primary options are going and hiring a full-time engineer who works on your team. And we've kind of already hit on one of the downsides of that, which is that there's an opportunity cost to hiring an engineer in a particular discipline that you miss out on all of the other disciplines that they could have. And then, of course, there's economic incentives to not do that, which is, you got to pay that person full time. You got to pay their payroll taxes. So a lot of people want to move away from that. Another option would be going on one of these freelance sites like Freelancer or Upwork.com and hiring somebody maybe in the US who works independently, maybe overseas in Asia. And of course, there's lots of great freelancers. But again, if you need different disciplines, you're forced to kind of cobble together that team.
Yeah.
And then you have to be project manager for that.
And so it seems like that's where your business comes in, because you're kind of coming across as a very well-rounded engineer.
Exactly.
Sort of a unicorn.
Oh, well, I have a great team behind me, and I respect their knowledge and their disciplines, and I listen to them when they say
things. I think we get that. I think we get that you're not doing all the jobs, but you do seem to have a very well-rounded point of view in terms of how you are building your team, how you're communicating with the different parts, how you're working and sourcing these jobs. Because really in business, a lot of times he who makes the sale owns the client.
Right.
And so your technique of going out there and procuring these jobs is a little bit atypical for an engineer type person.
Oh, absolutely.
So what is it that makes you different? Why are you so well-rounded?
I wouldn't say that I'm particularly well-rounded. I would just say that I respect that each of these disciplines are expertise. They have expertise in their own field.
Okay, but that behavior of putting yourself out there, a lot of times engineers are introverted.
Oh, yeah,
they're not
absolutely.
extroverted.
Yeah, there's a stereotype about that, and certainly a portion of engineers fit into that stereotype. I wouldn't say that anybody on our team fits into that stereotype.
Okay, that's really cool. How were you able to find those people?
These are just people that I knew and people that when we reached out and solicited for these positions, these were the people that approached me and that appealed to me the most.
I gotcha. Well, that is kind of exciting how you're putting this whole thing together. How are you seeing your model scaling to the next level?
Oh, absolutely. So I have a feeling that the kind of old way that most companies interact with engineers,
of hiring a full-time engineer,
that's going to go away. I think that companies are going to interact with engineers more like they do doctors and lawyers and less like they do assistant managers. And we've already hit on one of those reasons. Okay. It's the opportunity cost that comes with the discipline. Furthermore, there's an incredible financial incentive for an engineer to break out on their own. A lot of them don't realize it yet because the schools are pushing, go get a job, go get a job. Right? Here's something else that the schools are pushing, though. Be interdisciplinary. A person can only be so interdisciplinary. A lot of engineering students hear their professors saying, you need to be more interdisciplinary, and the reaction is...
What does that mean?
It means, like, you're a mechanical engineering student, you need to know about as much about as electrical engineering as you possibly can.
Okay.
And the reaction is, I'm struggling to understand my own discipline, let alone understand somebody else's.
Yeah.
So, but that pressure is on them because of that opportunity cost that comes with hiring an engineer.
Right.
It's easier for a company to hire an engineer who presents themselves as interdisciplinary than somebody who presents themselves as an expert in some narrow field, because chances are their product is going to combine more than one discipline.
That makes sense. I mean, there could be even materials like glass or plastic where you need to find a specialist.
I'll tell you a story. So one of the things that we took in mind when we were building this company, at least I did, obviously I'm 24 years old. I don't have a whole lot of experience. So if I had started from the premise that experience was really important to building this business, it would have been a non-starter, right? So I started from the premise that maybe experience, respectable as it is, isn't as important as everyone makes it out to be. And I had a recent experience that kind of confirmed that.
Sure.
We were working on a project, and this is a project that's ongoing, and we were doing production sourcing, and we were speaking with a manufacturer, and there was a revision that we were discussing, and manufacturer, he's fantastic, of course, he had a suggestion that he made that, and this is a guy who has 30 years of experience that everybody's looking for.
Right.
And that suggestion, I weighed it against a recommendation that was made by our materials engineer earlier in the process, and I realized this isn't going to work. And when I pointed it out to him, he said, oh, I didn't know that, right? So here's an example of experience versus pure expertise and discipline. And we saved ourselves and we saved our client from an extremely costly mistake in that circumstance. So that's really the value.
Well, I certainly respect that you were still open-minded to listening to them.
Absolutely.
Right. I mean, he may have known something about how his machines worked or something that, even though you knew the materials, he might have known something about manufacturing.
Right. And that's why there's a revision process where we assess manufacturers' capabilities and we tune the product to their capabilities. But really that one instance stood out to me. Like, here's a guy who's been working in this industry for 30 years.
Yeah.
And he's fantastic, don't get me wrong. But had we not pointed this out, had we not brought on a materials engineer, which is an extremely rare discipline,
right?
Also another niche discipline. In fact, I would say very few product design firms have a materials engineer on their team, then we would have missed out on that, and it would have been an extremely costly mistake.
And I mean, at its core, that is the beauty, and that is the reason you have engineers. You're not just building stuff and hoping it stands up. You're actually doing the math.
Exactly.
Understanding things like coefficients and whether or not this thing is going to melt, or how long is it going to last in UV light. Right. So I certainly have a ton of respect for what engineers do. I started my college career as an engineer. Ultimately, I found that what I truly like is coming up with creative solutions. I like things that have maybe multiple right answers, right? But maybe one answer is what they call a heuristic. Maybe one of these answers is more right than the others, but I enjoy that part of the creative process and have a ton of respect for what you guys do. I am really interested in how you're building this team and how you're looking at sales. Do you have any sales experience other than what you've taught yourself?
I read a couple books.
Okay. What books?
I read Grant Cardone's books.
Okay. He is a very well-known sales guy, comes out of the automotive industry.
Right.
And enormous ego.
Of course.
Right.
He can afford it, though.
Well, he certainly has a track record of being effective and moving people through a sales process. And I think that's at the root of what makes his sales training so effective, is that he can take very average salespeople and improve them and make them better salespeople because just those steps along the way.
Right.
And do you use that process in your sales?
To a certain point. There were a lot of more generic lessons about how it's all a numbers game that I sort of derived from these books that were extremely helpful for me.
Yeah. That is cool. I mean, a lot of times it is true. It is a numbers game when it comes to sales. It's hard to get truly, truly emotionally connected to an opportunity because, like, I get super enthusiastic and excited about different projects that come across my plate. But it is like there are certain things that you can't control, and you'll win and lose some of those deals. But ultimately, it comes down to whether or not you're trusted to be the right solution for that.
Yeah, exactly. I mean, I still think about projects that we got approached about like early last year, that I thought, oh, this is so exciting. We're going to build such a cool product. And then it just went nowhere. But ultimately, we're going to have more projects. We have more projects that we're talking about right now. And so we can forget about those.
But that is super cool. I really have a lot of respect for what you're doing. And it's almost like it was born out of necessity because you didn't know you were going to start your own business.
Oh, yeah. If you asked me in college, I would have said, are you crazy?
Yeah.
I'm going to go get a job.
Right. But a job isn't always everything it's cracked up to be.
No, and I think increasingly it's less what it's cracked up to be. If you look at the average engineer's resume today, used to be that you'd get somebody who works for the same company for years and years and years in the same department doing the same thing. Then it became, well, they work for the same company, but they maybe hopped around different departments, worked on different projects. Now, the resumes are all over the place. People are spending maybe 3 years at a company, and that would be a long time before they move to a different company. And so what's the logical conclusion of that? Well, it's our kind of work where we split time between different clients to be economic to them.
Okay, so you're offering them like a lower price but similar value.
Exactly. And the thing about product development is it's cyclical. So there's a portion of time where the design team is working really hard and they're creating a lot of deliverables, and then those get sent out, and then the design team maybe isn't doing anything because they're waiting on something to come back in from somebody else. So if you're a company that is conscious about your budget, then you don't want to have that design team on your payroll for the entire year.
Yeah, it comes and goes. Are there any products out there like the iPhone or anything you see in sporting goods? Are there any products out there that you feel like are just like wonderful examples of like superb design?
Oh, I'd have to think about. Yeah, actually, I brought a little example with me because, manufacturing is a big thing. So I wanted to talk about this. Recognize this?
I've seen that before.
Yeah, this is just a regular old bottle cap off a plastic water bottle that I drank yesterday. And I thought, hey, I'd bring it with me today. So a lot of people ask me about injection molding because they're thinking about plastic products, right? And the way that you can tell, I tell this to everybody, the way you can tell if something can be easily injection molded is you look at it from two opposite sides and you say, if I can see all of the faces from those two opposite sides, then it can probably be injection molded and injection molded relatively easily. If you can't, if there's any faces that are kind of hidden, then that's going to be a more complicated part. So at first glance, you look at the top and you say, yeah, I can see all of the faces, and you begin to realize that, hey, the ends of this are kind of flared outward, and that's why. Then you look at the bottom, and you say, at first glance, yeah, I think I can see all the faces, but if I had really good eyesight, I'd realize, what about the threads on the inside? I can't see the other side of the threads. Yeah. So how do you mold something like this?
How do you mold something like that?
So you have a core, like all parts. You have a core that it gets molded onto, and you have a cavity that it gets molded within. Plastic flows in to the cavity. you can actually see where it flows in. This is a dead giveaway for something that's injection molded. That little nipple right there.
Sure.
You can feel it if you rub your fingernail across it. That's called the gate. That's where the plastic flows in. Plastic flows in there. It cools, so it contracts. It gets stuck to the core. Then the mold comes apart. Cavity comes off. The part's still stuck to the core. Normally, you'd have another part that comes by and it strips it off of that core.
Okay.
You can't do that, though, because it's got those threads. You'd rip those off. So what do?
Unscrew it.
Exactly. So now you're beginning to realize that this is an extremely complicated piece of machinery that has to close. Plastic flows in, cools the plastic, comes apart, unscrews, and then the part falls off and it does it again. And you begin to realize that, hey, this is something that someone, or rather a lot of someone's, spent a lot of time thinking about the value of this thing, right? And the value of investing all that money into that equipment and producing it. And for what? Ultimately, it's something that you're going to take and you're going to use once and you're going to throw in the trash can. But your beverage would not be nearly as usable if you didn't have this. You could probably seal it in a different way so that it could at least get to you, but you certainly wouldn't be able to drink half of it and then put it in your backpack and go somewhere else with it. So when you look at something like this, you begin to realize how much thought goes into the things that are around us and that we use every day.
Yeah, I'm really lucky. My grandfather, who also went to the same college we went to, he spent a lot of time pointing out little details to me.
Oh, really?
He was an industrial engineer, not an industrial designer. He was industrial engineer, and he started off aeronautical engineering. And I mean, we would just be hanging out, and he would point at a building or some kind of a support of something, and he would always say, "Cords, like, look at that. You know, look how smart they were in figuring out that one little piece." And so I always think about things like that when I see little elegant designs like that. But that is a really useful one. I mean, I would imagine they're making millions and millions of those, maybe even close to millions a day of those bottle caps, and it's very utilitarian. It's very useful. And it does exactly what it's supposed to do, and it looks very inexpensive, and that's why people like injection molding, because it can make manufacturing of something very, very inexpensive, right?
Well, a lot of people, myself included, have a love-hate relationship with injection molding because of those tooling expenses that come early on. A lot of other manufacturing methods don't have that. You can just get started and go. But once you've crossed that hurdle, then the price for running your mold and producing 10,000 of your part is relatively low.
And so tooling itself, the definition of tooling, a lot of times people think of tooling and you're thinking of like, okay, I'm going to go to that department in Home Depot.
Right.
But when you mean tooling, you're actually talking about custom machines.
Exactly.
That are building something.
Exactly. And in this case, it would mean a mold. And when I was younger, before I actually worked in an injection mold tooling shop, I would look at a part like this and somebody would say that came out of a mold, and I would think of something that's roughly the size of this, you know, maybe a little bigger, but a mold for a part like this would probably have 8 cavities, 10 cavities. It would be this giant piece of steel, probably wouldn't fit on this table that we're sitting in front of.
That's incredible to think about. So those people who have an idea, right? They have some idea, they've got an improvement for something. What is their first step in working with a company like yours?
Gotcha. Yeah, so the first step is confidentiality. We want to make sure that their idea is protected, and more to the point, even if they do trust us, we want to make sure that in their communication with us, that doesn't count as a disclosure, which could preclude them from certain patent protection.
Interesting.
So the first thing that we do is sign a document called a non-disclosure agreement or an NDA to make sure that, hey, everything that happens between us is basically a secret.
And so at what point in my little process, so do I need to work with you? Is it very, very early on?
Yeah, we can take somebody from very beginning, concept design, all the way through to the end production support. In fact, that's what we did for that project we spoke about earlier, the Hopper rack station.
Yeah.
These guys, they had their deadline, and we engaged with them in early March of 21. And I remember the first day that we met at their warehouse in St. Pete, and we were literally playing with cardboard boxes around their vehicles, saying, oh, we could have something that, sort of bends up like this and looks like this and comes around the vehicles like so, and the bikes and the scooters would fit together like this. And we went from there all the way to, we have a product that is in quantity and is out in the streets in Rochester, New York. I think that was July of 21. So March of 21, we're in the concept design phase. July of 21, we have gone through production support and we have a fully produced product.
So it's been a few months. How successful has that product been?
So they had to actually take it off the streets for winter, but I believe that they're bringing it back onto the streets. Reception was really good. It was out in the newspapers, and ultimately, they've continued to work with us on other products. So I assume that they were pleased with it.
Yeah, well, that makes sense. So what's next for you guys?
We have several ongoing projects that unfortunately I can't get into, but several of them we expect are going to be coming out onto the market this year. And then beyond that, we're just looking for new clients. The ideal client for us is a company, maybe a smaller or mid-sized company that doesn't have a design team with them that's looking to develop a custom product, and they need some help with that.
Sure. And, a lot of times we get clients that way too. A lot of times you'll work with a distributor or someone who touches a lot of businesses, and it comes out that like, okay, you've invented this amazing thing. Like, how do you actually market it?
Right.
Right. And so a lot of times, those relationships are important to pull you into that process. Where can people follow you? So once these products come out to market and you're allowed to talk about it, I assume you're going to be posting on your social media.
Absolutely. Yeah. So you'll find us on LinkedIn. You'll find us on Instagram. You'll find us on Facebook. And of course, everything's on our website, emergentdesignlabs.com.
emergentdesignlabs.com. And then what are your handles for your social media?
Instagram would be at Emergnt Labs. And there's a little bit of a spelling thing there. So I assume all of this is going to be in the description.
Sure.
Great. Yeah. So I would advise that you go check that out in the description.
Great. Well, thanks for joining us, Jeremy.
Absolutely.
Appreciate you having on the show and educating us about the actual process of building things that are truly tangible, which is so cool these days.
Yes.
Everything is so digital. It's nice to have things that are actually made. And you can follow us anywhere where podcasts are found, on the bakemorepies.com website, the Law of Relevancy website, and all of our social media channels. Thanks for joining us. We'll see you next time.